The next topic in Packet 4 is solving quadratics. So for this first couple of videos, we're going to talk about the square root property and then factoring. And then in Packet 5, we will finish up solving quadratics by talking about the quadratic formula, which you all know is my very favorite way to solve quadratics. So when we are solving quadratics, we are solving for x. And this x value represents the x-intercepts, which are also called roots, zeros, or solutions. So remember that the graph of a quadratic looks something like this, and if it were on a coordinate plane, we are solving for the x values which represent your x-intercepts, or where it crosses the x-axis on a coordinate plane. So the first way we learned how to solve quadratics was using the square root property, and the square root property only works when you don't have a b term, so no b value. So if you just have an a and a c, the square root property is the easiest and quickest way to solve a quadratic. So this first one says x squared equals 36, and I'm just going to rewrite it down here so it's a little bit bigger. Once you have your squared term isolated, so all we have on this left-hand side is x squared, you can take the square root of both sides. When you take the square root of both sides, the square root of x squared is x, and the square root of 36 is positive and negative 6. Positive 6 times positive 6 is 36. Negative 6 times negative 6 is 36. So we always have that plus and minus sign whenever we're taking the square root. Number 10 is very similar, but this time we don't have our squared term by itself. Right now, this quantity m plus 6 is being squared because it's in parentheses, and we have a plus 2 on the same side as it. So I'm going to subtract 2 from both sides, and now I have m plus 6 squared equals 25. Now that I have my squared term, or my squared expression by itself, I can take the square root of both sides. When I take the square root of the left, I get m plus 6 equals plus or minus 5. The square root of 25 is 5. Now, because you have a plus and a minus, you actually have two problems to set up. You have m plus 6 equals 5, and m plus 6 equals negative 5. So basically, it breaks it down into two problems, and you're going to get m by itself. So first by subtracting 6, m equals negative 1, and then subtracting 6 from negative 5, m equals negative 11. So your two solutions would be m equals negative 1 and m equals negative 11. Number 11 is an application problem where they want you to solve or rearrange for y. So we talked about rearranging formulae in Packet 1. So if you're still having a hard time with that, I really recommend redoing that packet because it'll give you that extra guidance and extra support that you need. I'm going to rewrite this problem. X squared plus y squared equals 100. And I'm trying to get this y by itself. But before I can get y by itself, I have to get rid of anything on the same side as it. So I'm going to subtract x squared from both sides. And I get y squared equals 100 minus x squared. And then I can take the square root of both sides. Y equals the square root of 100 minus x squared. And you can leave it just like that, because you're not going to take the square root of 100 and the square root of x squared. Perfect. Moving right along, number 12 is very similar to number 10. We're going to take this, because our squared term is already by itself, we don't have to move anything around. So when I take the square root of both sides, I get x plus 8 equals plus or minus 3. So I have x plus 8 equals positive 3. X plus 8 equals negative 3. Subtract 8 from both sides. I get x equals negative 5. Subtract 8 from both sides. I get x equals negative 11. Notice that you almost always have two solutions, and that's because, remember, you almost always have two x-intercepts when you graph a parabola. In the next video, we'll talk about factoring using the MDRK method and finding the greatest common factor. And then last, we'll talk about the quadratic formula.